I was thinking about ordering the steak or the pork, but I just can't decide.
I think you should buy a nice good old steak because it only costs $3.60.
Get a hot dog or two because they're only $1.20.
And I only have $36.
Our price of hot dogs and its quantity each, plus the price of steak times the quantity of steak. Right? So if we're going to figure out how many hot dogs we're going to buy, how many total hot dogs we can buy given our budget, we're going to say that we're not going to buy any steak. No steak. So 36 being our budget equals price of hot dogs at a particular quantity plus 0 steak. That's no steak. So then we just do the algebra here. And our quantity H equals $36 divided by $1.20. Okay. Man, how convenient, it's already there. So the most that we can buy with our $36 budget is 30 hot dogs at $1.20. I've been working in an engineering office, guys. I'm a really smart cow.
The indifference curve is how I feel about hot dogs and hamburgers. So the indifference curve is a graphical curve that shows the combination of two goods in which they yield the same levels of utility. So points A, B, and C at these points all yield the same level of utility. And coincidentally enough, point A at 224 is the same, is found on our budget line. So when we draw in our budget line from 30 to 10, it perfectly goes along and hits, and therefore this is the maximization of our utility. Please stop playing. So therefore this point at A is the maximization of utility at the given prices.
Given budget.
At the
Given
given
budget.
at the given budget at the specific prices. Okay. Well,
It's imaginary.
we know that our slope is -3 over 1, meaning that when we increase our stakes by 1, we decrease the amount of money we spend on our hot dogs by 3 hot dogs. And so when we go down 3 on hot dogs and we get to 27, we've bought 1 steak. And it's the same when you go to 24 points and then you buy 2 steaks. Okay, so to find the slope, your formula is y1 minus y2 over x1 minus x2. Your y-intercept points are 0, 30, and your x-intercept points are 10, 0. So then you plug in to the formula. Your y1 is 0, minus your y2, which is 30, over your x1, which is 10, minus your x2, which is 0, which will give you -30 over 10, which equals -3 over 1. So, since this is your slope, come over here to your graph, and you will go down 3 and over 1 until you hit your point, which is on the budget line and the indifference curve, like our point. points, which is 24. You go over 2 and down 24. And for an additional steak, I decrease the amount of hot dogs I can buy by 3 based on my budget that is $36. The most hot dogs I could buy is 24, and the most steaks I could buy is 2, being on the maximum point of my budget.
We're gonna change the price now of steak, and it's gonna go to $1.20. So now we have to create a new budget line. So, so we'll start with steak, and so our maximum budget is $36, and the price of steak is $1.20. So we want to figure out what is the maximum amount of steaks we can buy at $1.20 for a budget of $36. When you divide that, it equals 30. And since our hot dog price is $1.20 as well, it's going to be the same thing. So it equals 30. So once we do that, now we can go over and graph our budget line. So we'll put a point at 30, so that's the maximum amount of hot dogs you can buy and not buy any steak with the budget. And then this point, which is at 30 as well, is the maximum amount of steak you can buy, not buying any hot dogs with the budget. So graph our line. So once we do that, it changes, because of the budget, it changes our slope. So the slope changes to, it's -1/1, and for an additional steak, one additional steak, I decrease the amount of hot dogs I can buy by 1 based on my budget. So because the price of steaks have decreased, we can now afford more steaks and hot dogs. The new budget line hits the indifference curve at 1020, which is right here. So 1020, point J. Therefore, point J is the maximization of utility relative to the indifference curve and the maximization of budget in terms of the price of steak and hot dogs.
If point J is the best spot, why don't we say then let's go up to the other indifference curve and have even more total utility? But we can't do that because we have a fixed budget, and so we're constrained to our current budget line. Oh, okay, so the marginal rate of substitution refers to the amount of one good that we would give up in order to be able to purchase the other good. And so in this case, if we're still above our point J, we're going to have to give up hot dogs in order to allocate the money to buy the steak. And that's happening at a rate of 1-to-1 because our slope is -1.
So I'm going to be talking about this graph here and transferring over to a demand curve of steak. So we start with our price and our quantity. And now that we have a change in price and quantity, or a change in price with our first demand or budget line, we can kind of show it on our demand curve. So at the price of 120, and we're increasing price, so the price of 360, and the quantity increases of our intake of steak, or how much we want to take. We have 10 and we have 30. So at the price of 120, we decided that we would intake 30. So we're going to point right here, the price, quantity. And then the price of 360, we only intake 10. So connecting these lines shows that we have a negative slope, which is what a demand curve is. And this shows that we have with an increase in price or a decrease in price and an increase and decrease of quantity. So as the price increases, we have a movement along the demand curve. So as price increases, we also have a decrease in quantity. So we go to here, and we move up. So we shift along. We don't shift along, sorry, we move along, no shifting. And then as opposite, so when price goes down, we move along the demand curve, and we go down, and that's where we would have a higher intake of steak. So have you made a decision?
No, I still can't decide.
But did you take into account my price change? There's a whole new difference, or a whole new difference curve. Got a new budget line and everything.